Dear all, greetings. Welcome to the session of divisibility rules. Divisibility rules are the part of the numbers, and these rules, the divisibility rules, are very important to check whether a given number is divisible by some other number or not. Now, these divisibility rule will help you in understanding and checking your answer, particularly in a integrated reasoning section, in a data interpretation section, and many times in the problem solving section also, right? So first of all, we should understand, okay, what are the different divisibility rules and how do they follow. So these are the divisibility rule which are a subsection, subdivision of a part of the numbers, right? So starting with the divisibility rule of the first very simple number, that is 2. So this is what this is, divisibility rules of powers of 2. So how the different powers of 2 will be taking a divisibility rule and dividing us some different numbers, right? So this says an integer is divisible by 2 raised power n. Yes, this is what this is, divisible by 2 raised power n if the number formed by truncating its last n digit is divisible by 2 raised power n, as the remainder of the original number is same as the remainder of the 2 raised power n formed by truncating the numbers. So now first consider the some example. Suppose if I say there is a number 2 4 9 6 8 3, right? And I want to check whether this number is divisible by 8 or not, right? So what is 8? 8 is nothing but what? This is 2 raised power 3. Done. So what I need to check here, I need to check if the last 3 digits of this number, that is 683, are divisible by 8, then this number will be perfectly divisible by 8. Right now we are having what? 683, and 683 is not divisible by 8. So this number will also be not divisible by 8, right? Now, so this is what this is, a divisibility rule of power of 2. So different power of 2, just like a 2 raised power 1, 2, 2 is square 4, 2 raised power 3 is 8, 2 raised power 4 is 16, 2 raised power 5 is 32, 2 raised power 6 is 64, and so on. So we should check a 1 digit, 2 digit, 3 digit, 4 digit, 5 digit, or 6 digit for checking the divisibility of all these numbers, right? Now, moving further, the divisibility rule of the next variety of numbers, this is what? Divisibility rules of the powers of 5, right? This is almost the same as we have discussed for the power of 2. So this says an integer is divisible by what? Yes, this is 5 raised power n if the number formed by truncating its last n digit is divisible by 5 raised power n. Else, the remainder of the original number is same as the remainder of 5 raised power n from the truncated numbers. So for example, just consider this. Suppose if I say there is a number 2, 9, 4, 3, 8, 7, right? And I want to check if whether this number is divisible by 25 or not. So what is 25? 25 is nothing but 5 square. So yes, what I need to check here, I need to check the last 2 digits of this number, that is 87. If divisible by 25, then this number will be perfectly divisible by 25. Right now 87 is not divisible by 25. So this number will also be not divisible by 25. So these are the rules for the power of 2 and power of 5. Now moving further and checking say some more rules for the different numbers, right? So some more rules for the different numbers, right? So the next variety of number is what? Divisibility rules of 3 and 9. Yes, what are these rules? An integer is divisible by 3 or 9 if the sum of its digit, yes, this is very important, if the sum of its digit is divisible by 3 or 9, as the remainder of the original number is same as the remainder of the sum of digit from 3 or 9. So now consider an example. Suppose if I say there is a one number 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I want to check if whether this number is divisible by 3 or not. So what is the rule? First of all, we add all the digit of this number. That is, we have to get the sum from 1 to 9. So what is the sum from 1 to 9? This is 45. So 45 divided by 3, right? So when you are checking now the remainder, so remainder is coming out to be 0, right? So I can say this number will be perfectly divisible by the 3. So what is the rule for 3 and 9? The rule for 3 and 9 is the sum of digit of the number should be perfectly divisible by 3 or 9, right? Now moving further, the next very important rule, this is divisibility rule of 11, right? So what is this rule says? Call u, yes, as a sum of all the alternate digits of the number starting from the unit place, right? Call t as a sum of all the alternate digits of the number starting from tens place. Done. If u minus t, that is a sum of all the digits starting from unit place and sum of all the digits starting from tens place is a multiple of 11, then the original number is perfectly divisible by 11. Else, the remainder of the original number is same as the remainder of these difference, that is the sum of the digit at unit place and the sum of the digit at the tens place when divided by 11, right? So just now consider a one example. I just take a one example. So suppose this is 2, 4, 9, 6, 8, 3, 7, 1, right? And I want to check if whether this number is divisible by 11 or not. So what to do? I just need to take the alternate digit and take the sum. So I can take this is 2, then this is 4, right? This is 9, then this is 6, right? This is 8, then this is 3, this is 7, and this is 1, right? So I have separated all the digits, then just add all these digits, right? Just add all these digits. So 9 plus 2, 11, 11 plus 8, 19, 19 plus 7 is 26, right? 19 plus 7 is 26. So this sum is coming out to be 26. Done. And take the sum of this also. So 4 plus 6, 10, 10 plus 3, 13, 13 plus 1, 14. So this sum is coming out to be 14. Done. Now what you have to do, you have to take the difference of this. So this is 26 minus this is 14, right? Now what is the difference is coming? 6 minus 4 is 2 and 2 minus 1 is 1. So now the difference is coming out to be 12. Now, if this difference is what 0, 11, 22, 33, 44, or a sum number which is a multiple of 11, then this number will be perfectly divisible by 11. Right now, you are getting a difference is 12. So this means this number will not be divisible by 11, right? Now, if I want to ask you what is the remainder? So what is the remainder? The remainder you will be getting the same when you divide this difference. So when 12 is divided by 11, remainder is 1. So when you divide this number properly by 11, you will also get the remainder as 1, right? So these are the rules for the power of 2, power of 5, for 3, for 9, for 11, right? Now moving further and checking some more rules for different numbers, right? So moving example, right? So now this is the rule for what? A very important number, which is 7, right? So we are just now checking a rule for the 7. So this is number, I'll take say 2, 4, 8, 3, 9, 1, 7, 5, right? So this is a one number. Now I want to check if whether this number is divisible by 7 or not. So what to do? Starting from your right hand side, right? Starting from your right hand side, make a group of three digits, right? Make a group of three digits. One is this, one is this, and one is this. If you are not able to make a group of three digits, just add a 0 in the beginning, right? To make a 3-digit group. So this is the first group, this is the second group, and this is the third group, right? Now separate these groups. So this is 0, 2, 4, and 1, 7, 5. So when you are separating the groups, just take care, you should separate the group placed at odd places and placed at even places, right? So I am clubbing the odd place group, that is 0 to 4 and 175, and the other is what? This is 839, right? So this is just one group, so this is only the 839. Then add this, 4 plus 5 is 9, 7 plus 2 is 9, and this is 1, right? So now you are getting a two different sums. So one is 199 and one is 839. Now take the difference of these two groups. So this is 839 and this is 199, right? So yes, 9 minus 9 is 0. Now this is 13. 13 minus 9, right? 13 minus 9 is what? This is 4, and this is 7. 7 minus 1 is 6. Right? So this difference I am getting now as 640. Now check if this difference is divisible by 7 or not, right? So this difference is 640 and this difference I can say is not divisible by 7. Now suppose if this difference is coming out to be what? 0, 7, 14, 28, 56, or some number which is a multiple of 7, then this number will be perfectly divisible by 7. Right now the difference is not divisible by 7, so this number is also not divisible by 7, right? So these are the rules for what? These are the rules for the divisibility of 7, right? The same rule is also applicable for 13, right? The same rule is also applicable for 13. So what to do in this 13? I can have the same thing. Just take a number, make a group of three digit, right? And then add them, then subtract them, take the difference. And right now here, what the difference you are getting the difference as this 640. Now, can I say that this 640 is divisible by 13? No, this is not divisible by 13, right? So if this difference is a multiple of 0 or 13 or 26 or 39 or some other number which is a multiple of 13. So this number will also be divisible by 13. So this is the rule applicable for 13 also. So the rule for 7 and 13, both the rules are same and can be applicable in the same manner. The change is at a last step when you are getting this difference. So if this difference is a proper multiple of 7, then the number will be divisible by 7. Or if this is a multiple of 13, then the number will be divisible by 13 and so on, right? So difference can be for 7, 7, 0, 14, 28, 56 or some number. Similarly for 13, this can be 0, 13, 39, 26, and so on, right? So all these numbers are there, then all these numbers are divisible by 7 or 13 respectively, right? Now, moving further and taking us some example to understand the applicability and the application of all these divisibility rules, right? So how to get and how to apply all these rules. Now, say this. One example is the 9-digit number, this 9-digit number ABCDE 9025 is divisible by 625, right? So what rule we apply here? We apply the rule for what? That is a power of 5, right? So this is a number A, B, C, D, E 9025, and I need to check whether this number is divisible by 625 or not. So what is 625? 625 is nothing but 5 raised to power 4, right? So what I need to check here for the divisibility, the number that is this 9-digit number, out of this 9-digit number, the last 4 digit, that is 9025, if divisible by 625, then I can say that this number will be perfectly divisible by 625. Right now, 9025 is not divisible by 625. So I can say what my answer will be this second option, that is no, right? So my answer will be here, that is no. This number will not divisible by 625, right? So this is the applicability of the rule, that is a power of 5. Done. Now moving further, checking for the next number, next question. Yes, yes, this is if the 8-digit number x76554321 is divisible by 9, where x is a single digit whole number, then find x. So we have to find the value of x. When this number, 8-digit number, is divided by 9, then I need to find the value of x. So what is the rule for 9? That is the sum of the digits should be divisible. So I can say this is x plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. If this is divisible by 9, then I want to check what is the value of x, right? So if I add all these things, so I am getting what this is 28 plus x divided by 9. So it means what this 28 plus x, the numerator should be now divisible by 9. Now tell me one thing, after the 28, which is the number, which is divisible by, exactly by 9. This is 36, right? So if I take some such value for the value of x, if added to 28, and this will make as 36, right? So can I take the value of x as 8? Right? So if I put x as 8, this is what this is 28 plus 8 divided by 9, and this is what that is 36 divided by 9. So now I can say that this is perfectly divisible, and my remainder is what? My remainder is coming out to be 0, right? So what is the answer for this question? What is the value of x? Value of x will be this, that is 8, right? So I can find out all these questions with these divisibility rules, and here my value is coming out to be 8, and the value of x is 8. If I put the 8 in place of x, then this complete number, the 8-digit number, will be perfectly divisible by 9, right? Now moving further and checking one more application of such divisibility rules, right? Now, yes, this is again a very important example for the rule of 11. No? So this is which of the following is divisible by 11. So what is the rule of the 11? The rule of the 11 is what? Sum, sum of digits, sum of digits at at even place, sum of digit at even place, right? And what difference, right? Sum, sum of digits, sum of digits at odd place, sum of digit at odd place should be what? Should be a multiple, yes, should be a multiple of what? 11, right? So this is my rule. So I can check the options for this divisibility. So if I take the first option and separate the digits, so this is 8 plus 8 plus 8 plus 8, that is a 4 8. So this sum is coming out to be 32. Then I have 7 plus 7 plus 7, right? So this is coming out to be 21. So these are the two sums. Now I need to check what the difference. So this is 32 minus 21, and this difference is coming out to be 11, right? So this means what? This number will be perfectly divisible by 11, because the difference of alternate place sum digit, right, is coming out to be a multiple of 11. So this number will be perfectly divisible by 11. So here my answer is what? That is a first option, and I can mark my answer as a first option absolutely correct, because here I am getting what? The difference of the alternate place digit, that is coming out to be a multiple of 11, right? So these are the different rules, these are the different divisibility rules for a different varieties of numbers. So I just again repeat one more time for you. See this. So the different rules which we have done here are what? First, we have done the rule what? Power of, yes, power of 2. Done. This we have done. Second is what? Divisibility rule for power of 5. then divisibility rule of 3 and 9. Then we have done the divisibility rule for, yes, what, 11, right? We have done the divisibility rule for 11. And then I have discussed with you the divisibility rule of 7 as well as 13, and took us some example and solve for you and explain you and demonstrate you how these rules are applicable for these different varieties of numbers and the different questions, right? So with this, I'm just winding up this session, and I'll be giving you very best of luck for your preparation, and just revise the question from the booklet. And if there is some concern, you can just always get us to the EduShastra team for your queries and for your doubt clearing sessions. Thank you. Thank you very much.